The next problem is adopt. A1, A2, A3, A4001 are in AP. 1 by A1, A2, 1 by A2, A3, 1 by A3, A4, 1 by A4000, A4001 is equal to 10. A2 plus A4000 is equal to 50. Find mod of A1 minus A4001. Mod of A1 minus A4001 is equal to how much? So this is our next question. A1, A2, A3, A4001, they are on AP. One condition is given like this. Right, listen. See, the point here is this 1 by A1, A2, this equation when you observe, all of you know A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 is equal to A4001 minus A4000, each is equal to common difference. So you multiply on both sides with D. D by A1 A2, D by A2 A3, D by A4000, A4001 is equal to 10D, like this. You replace D with A2 minus A1 by A1 A2, A3 minus A2 by A3 A2, A4001 minus A4000 by A4000 A4001 is equal to 10D like this. This is this by this, okay, 1 by A1 minus 1 by 8 plus this by this 1 by A2 minus 1 by A3. Finally 1 by A4000 minus 1 by A4001 is equal to 10D. Telescopic cancellation like this. So finally you are going to get 1 by A1 minus 1 by A4001 is equal to 10D. This is what you are going to get. Okay, understood? Now this is as good as A4001 minus A1 by D is equal to 10 A1 A4001 you will get. Bring D to this side. A4001 is equal to A1 plus 4000D. So A4001 minus A1 is equal to 4000D. You substitute. 4000D by D is equal to 10 A1 A4000. Yes, okay, right. DD will go. So A1 A4001 is how much? You will get 400. Right. See what is given. A2 plus A4000 is equal to, I think, 50. You should remember one point in an AP, first term plus last term is equal to second term last but one term. So this is also as good as A1 plus A4001. So this is as good as this, first plus last is equal to second plus last but 1 like that. So you got x plus y, you got xy. You require what? A4001 minus A1 whole square is equal to A4001 plus A1 whole square minus 4A1 A4001. A minus B whole square is equal to A plus B whole square minus 4AB. So when you substitute in this is 2500 minus 1600, so 900. So mod of A4001 minus A1 is equal to how much? 30. This is your answer. Right? See, I think you follow that idea. 1 by A1, A2 means how to plan. You know A2 minus A1 is equal to A3 minus A2 is equal to etc. Common difference. Like that, you can plan this problem and do it. Okay, understood? So this is one of the important questions. So the next question is A1, A2, A3 are in GP. A1, A2, A3 etc. are in GP. A1 is equal to A. Common ratio is R. Common ratio is R. A comma R positive integers. A and R are positive integers. Number of ordered pairs. Number of ordered pairs A comma R such that sigma R is equal to 1 to 12 log AR to base 8 is equal to 2010. Log AR to base 8 is equal to 2010. So this is a very good question. Just watch. A1, A2, A3 they are all in GP. A1 is A, common ratio is R. And this is this particular point. A and R are what? Positive integers. The number of ordered pairs are satisfying this equation. See, actually, this is nothing but log A1 means log A. Correct? A1 is A only. Then what is A2 for you? AR. You all of you know GP. A, AR, AR square like that. So log AR to base 8. Finally, log of AR to the power of 11 to base 8 is equal to this. Base is what? 8. You all of you know logarithms. Log m plus log n is log mn. So, finally, log of A, how many times? 12 times. So, A to the power of 12. R to the power of 1 plus 2 plus 3 up to 11. Because R into R square into R cube into R power 11 you will get that. So 11, 1 plus 2 plus 3 up to 11 is what? 11 into 12 by 2 means what? 66. 11 into 12 by 2, 66. To base 8 is equal to this. Okay, understood? Same, you all of you know this. Log m to base n is x means m is what? N power x. So, a power 12 r power 66 is equal to 8 is nothing but 2 cube. 2 to the power of 6030 you will get. You will get like this. a power 12 r power 66. Now this is as good as a square r power 11 whole to the power of 6 is this. So what is a square r power 11? 2 to the power of 1, 0, 0, 5. So a square r power 11 is equal to 2 to the power of 1005 watts. Since a and r are positive integers, when you get an equation like this, a must be in the form of 2 power alpha, where alpha is what integer? R must be in the form of 2 power beta. So then only you will get an equation like this. A should be 2 power something, B should be, R should be 2 power something like that. Yes, understood? Because A and R are what? Positive integers. Understood? Now, this is as good as 2 to the power of 2 alpha plus 11 beta is equal to this. So 2 alpha plus 11 beta is equal to 1005 electrons. Now the question is number of values of integer values, positive integer values of alpha and beta satisfying this. So you first fix up beta values. Beta is equal to 1. Possible beta if I put 1, 2 alpha is equal to 1000, what will get? 94. So possible. Beta is what? 3. Beta cannot be 2. If beta is 2, 2 alpha will become what? Odd. Beta is next to 5, 7. What is maximum we can have? I think 91. So if beta is 91, what will get here? 2 alpha plus 11 ones, 1 is there, 99, so 1000. So you will get 2 alpha is equal to 4, alpha value 2 you will get, no problem. 92, 93 not possible. So these are all how many values of beta? See, 1, 2, 3 up to 92. 92 means 46 even, 46 odd. So 92 even if we remove, the odd integers are what? 46. So beta you can choose in 46 ways. Right? For every corresponding beta there exists one alpha. Therefore, number of ordered pairs alpha comma beta, that is A comma R, will be 46. So there are 46 ordered pairs A comma R of positive integers possible satisfying this equation. This is a very good question, a typical IIT question for you. I think the question is quite clear. First AR square you wrote, you just substituted. So everything will go smoothly up to this. Then after this also no problem. Now, since A and R are positive integers, since 2 power 1005 is there, you should assume A as 2 power alpha, B as 2 power beta, then only it is possible. Then you will get like this. Now 2 alpha plus 11 beta is equal to 1005. So since A and R are positive integers, alpha and beta must be what? Positive integers. What type of positive integers alpha and beta satisfy this equation is our question. For that, take the bigger one, beta. Beta is 1, 3, 5. So for every beta, there exists one alpha. So like that, there are 46 values of beta are possible. Hence, you will get what? Number of ordered pairs happens to be 46 like this. Okay, right? This is one of the important questions, right? See, the next question is log A to base 6 plus log B to base 6 plus log C to base 6. is equal to 6. A, B, C are positive integers forming increasing geometric progression. A, B, C are positive integers forming increasing geometric progression. B minus A is square of an integer. Then what is the possible values of A plus B plus C is the question. So if we closely look at this, this is as good as log ABC to base 6 is 6. So ABC will become 6 power 6. Right? ABC will become 6 power 6. Now I will choose A as, let us say, B by R. B is B only. C is what? BR. 3 numbers are in GP means I can select A, B by R, B, B only, C, BR. If I multiply all these things, this is your A for you, this is B for you, this is C for you. So if I multiply all of them, I am going to get what? B cube is equal to 6 power 6. B is equal to 36. Correct. B is equal to 36 watt. Okay, understood? B is equal to 36. Now, B minus A is equal to 36 minus A. He says B minus A is square of an integer. Remember, A is integer. When does 36 minus A will be square of an integer? When A is equal to 35. 36 minus 35, 1 is a perfect square. A is equal to, next what you can expect, 32, no? 32, so 4 is a perfect square. 27, 9 is a perfect square. Next possible values, 9, no? Next 20, 20, right, 20, 16 is a perfect square. Next is what, 25 and 11, A is 11, is a perfect square. Next 25, next 36, A cannot be 0 because positive integer. So these are all possible values of A you will get. Of course, B is already what, 36 for you. Possible values of A are like this. You should remember that C is also integer. C is also what? Integer. So listen, B by A is equal to C by B. So your C value how much? Your C value happens to be B square by A, which is 36 into 36 by A. Now the question is, among the values of A, which makes C a positive integer is our question. If you put A 35, fails. It fails, it cannot be integer. A 32, nothing fails. 36 into 36 by 32 cannot be integer. A 27. A is equal to 27 means 36 into 36 by 27. This is 9 fours, 9 threes, 3 12s. So, which is what, 48. So, C 48 you will get. So, A is 27, B is 36, C is 48, one value. We got one value like this. Then what is A plus B plus C under these conditions? 27, 36, how much? 60, 53, no, sorry, 63 plus 48, 111, right? Yes, 111 will get. Then next A is 20, I think 20 fails, 11 also fails. So therefore, A plus B plus C is equal to 11. This is also a typical question. So here you see this condition. B minus A is square of an integer. So B minus A is this. Then you should do a guesswork. For what values of A, B minus A will become a perfect square. First value is 35. B minus A is a positive because increasing GP. He has given increasing GP. Therefore B minus A is what? Positive. So 35, 32, 27, 20, 11 like this you got possible values of A. Then you got A and B and A values like this. Then C value. Remember C is also integer. How to calculate C? C is equal to B square by A. B square value substitute. But A is having various values like this. Among all these values, which will give C positive integer, that you have to inspect. So 35 fails, 32 fails, 27 only A is suitable. So when you substitute 27, you got 9 4s, 9 3s, 3 12s, 12 4s, 48. Right, okay. Right, A plus B plus C is equal to 111 like this. Okay, so it is also a typical question. Now, the next question is coefficient of x to the power of 8 in the expansion of x minus 1, x minus 2, x minus 3 up to x minus 10. We also write coefficient of x to the power of 9, the same expansion, x minus 1, x minus 2, x minus 3, x minus 10. Right? We will discuss these questions. Right? So, there is a quadratic equation, the coefficients of which are A plus D, A plus 2D, which are in AP, and given that they form increasing AP. Then what is the smallest integer value of D by A? Provided this quadratic equation is having real roots. Straight delta greater than or equal to 0 we put. So A plus D whole square minus 4A into A plus 2D greater than or equal to 0 will get. So this is as good as A square plus D square plus 2AD minus 4A square minus 8AD greater than or equal to 0. So minus 3A square minus 3A square minus 6AD plus D square like this. Okay, you divide with A square. Since A square is positive, inequality remains same. So D by A whole square 6 into D by A minus 3 like this. We got a quadratic inequality in D by A. What are roots of it? 6 plus or minus square root of 36 plus 12 by 2. So 6 plus or minus root 48. Okay. 2 root 2 48. You can take out root 3, you can put by 2. So this is 3 plus or minus root 3 will get 3 plus or minus 2 root 3. 3 plus or minus 2 root 3. So D by A will be less than or equal to 3 minus 2 root 3. D by A greater than or equal to 3 plus 2 root 3. Yes, then of in a quadratic equation greater than or equal to 0, this positive means D by A does not lie between the roots. This is what you got it. So what is the value of this 3 plus Root 3 is approximately 1.7 you take. You will get 3.4. So d by a greater than or equal to 6.4. What is the least positive integer value you can have? 7. So d by a, least value of d by a. Least value of d by a. Least integer value. Least positive integer value. Okay. So least positive integer value of d by a is equal to 7. This is how you have to do this. Which is of course very simple. Delta greater than or equal to 0 you should write, get a quadratic in d by a, quadratic inequality in d by a and solve it. This is how you have to proceed to do this problem. The next question is sum of n consecutive positive integers is given by 57 square minus 13 square. Sum of n consecutive odd positive integers. So sum of n consecutive odd positive integers is 57 square minus 13 square. Then find the value of n. And least integer, greatest integer among them. Least integer and greatest integer among them. So sum of n consecutive odd positive integers is 57 square minus 13 square. You have to find out least and you have to find out n. You have to find out what least and greatest integers in that series. See, the first one is, let us say, 2m plus 1, where m is what? Integer. M is of course, m value, m can take 0 of course. Next is 2m plus 3. Next is 2m plus 5, etc., n terms. Okay, right. Now, n by 2 into 2a means what? 4m plus 2 plus n minus 1 into 2 is equal to 57 square minus 13 square. You will get like this. You can cancel throughout 2. So n into 2m plus 1 plus n minus 1 is 57 square minus 13 square. 1 will go. This is n square plus 2mn is equal to this. You can write like this: m plus n whole square minus m square is equal to 57 square minus 13 square. You can write. I am making this a perfect square by adding and subtracting m square. Now m plus n is equal to 57 and m plus n is equal to 57, m is equal to 13. So n value how much for you? Subtract 40. M value 13 already known. So what is n value? 44. Least integer is what? M is equal to 13. If you put, you will get 27. Right? Next, greatest will be a plus n minus 1 into d, means how much you will get? 37 plus 45 into 2. Correct? Nth term. N is what? 44. This is least integer. This is the greatest integer you are going to get. A simple idea question. Right? Understood? Good morning to all of you. Today's first question is, a person has to count 4,500 notes. AN is number of notes. He will count in nth minute. A1 is equal to A2 is equal to A3 is equal to A10 is equal to 150. A10, A11, A12 are in AP with common difference -2. Then number of minutes required to count the notes. So a person has to count 4,500 currency notes. AN is number of notes he will count in nth minute. A1, A2, A3 each is equivalent to 150 up to A10. And moreover, A10, A11, A12, etc. they are in arithmetic progression with common difference -2. Then you have to calculate the time required to count all the notes. See, listen, we will plan like this. See, first, in 10 minutes, he will count how many notes? In 10 minutes, he will count 1,500 notes. Remaining notes are how much? 3,000. Let us say he will take n minutes to count all these notes. Now listen, here A10 is what? 150. A11 is how much for you? 148, because they are all in AP with common difference -2. So A11 is 148, A12 happens to be 146, etc. etc. Let us say he will take n minutes, let us say. Then what is this sum for you? N by 2 into 2a means how much? 296 plus n minus 1 into -2 is equal to 3,000. So like this, 10 minutes. Already 10 minutes over. In 10 minutes he counted 1,500 notes. Next to 3,000 notes, when he is counting, he will not count uniformly. That number of notes will count per minute will be a decreasing arithmetic progression with a common difference -2. So A11 is 148, A12 is 146, it goes like this. Let us say he takes n minutes time. The total sum must be equivalent to what? 3,000, like this. So finally, what you are going to get? You can cancel 2 throughout. So when I cancel 2 throughout, I am going to get 148n minus n plus 1 minus n square plus n is equal to 3,000. Send n to this side. So n square minus 49n plus 3,000 is equal to 3,000. You factorize 3,000 in such a way that the sum is 49. I think 24 into 25. 25 4 100. 25 2 25 4 150. No. N square is 148 kada. 149, right. So 24 into 125. So So n minus 24 into n minus 125 is 0. So n is equal to 24, n is equal to 125. You have to consider what n is equal to 24 only, because of it is a decreasing sequence. So n is 124. See, the sum is equivalent to 3000 when n is 24. Even if n is 125 also, it is that, but 125 is not possible because it goes to negative values. So n is 24. The total is how much? 24 plus 10, which is 34. Yes, understood? No. The next question is, the first three terms of AGP are 3, 4, 4. Find sum to infinite number of terms. First three terms of AGP are 3, 4, 4. Find sum to infinite number of terms. So A plus D into R, A plus 2D into R square, etc., etc. A is equal to 3. A minute. A is equal to 3. A plus D into R is equal to 4. A plus 2D into R square is also 4. So you can A value already. You can calculate what using these two D and R values. So you do one thing. A value substitute. 3 plus D into R is equal to 4. 3 plus 2D into R square is equal to 4. You square on both sides and divide one by the other, or otherwise you substitute this R value. 3 plus 2D by R value is what? 4 by this. 16 by 3 plus D whole square is equal to 4. So you can calculate your D value. You will be knowing A value, you will be knowing D value, you can get what? R value. Hence you can use the formula A by 1 minus R plus dr by 1 minus R whole square and complete this simple question. See, when you calculate R value, you should see that mod R value should be less than 1. Then only sum to infinite number of terms of AGB will make sense, otherwise it becomes what? Infinity. So when you get two values of R, see that mod R value less than 1 and proceed like this. Right. See, the question is coefficient of x power h in the expansion, coefficient of x power 9 in the expansion of this. See, to do this question, first you should remember the following thing. Suppose you come across x minus a1, x minus a2, x minus an like this. See, when you multiply, first the highest x power n you will get. Minus a1 plus a2 plus a3 up to an into x power n minus 1. So, this is a sigma a1 into x power n minus 1. Sum of the products taken one at a time. Sum taken one at a time, of course. Plus a1, a2, a1, a3, a1, a4, a1, an. Plus a2, a3 like that. Sum of the products taken two at a time into x power n minus 2. Then next sigma a1, a2, a3, x power n minus 3, etc., 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 like this will get. So you should first recall this point. Understood? Now, you observe this. There are 10 terms. So this is as good as x power 10 minus 1 plus 2 plus 3 up to 10 into x power 9 plus 1 into 2, 1 into 3, etc., etc. Taken 2 at a time into x power 8 minus taken 3 at a time into x power 7, etc., etc. will get. So what is x power 9 coefficient? It's very simple. Minus of 1 plus 2 plus 3 up to 10. That easily you can calculate. So coefficient of x power 9 means it is very simple. So x power 9 coefficient is nothing but minus of 10 into 11 by 2. The problem is this. See, in the theory I taught how to calculate the sum of the products taken 2 at a time. See, to get that, what you should consider? 1 plus 2 plus 3 up to 10 whole square is equal to 1 square, 2 square, 10 square plus 2 double sigma 1 into 2. This is your S. So shall I write like this? I will write like this. 1 square, 2 square, 10 square, 2s. Where s is coefficient of what? X power 8. Yes, I hope you are all following. So 1 plus 2 plus 3 up to 10 means what? 10 into 11 by 2. So you will get how much? 55 whole square minus 1 square, 2 square, 3 square up to 10 square will come to this side, which is sum of the squares of first 10 terms. N into n plus 1 into 2n plus 1, 21 by 6 by 2 is equal to S. So your coefficient of x power 8 has to be estimated like this. So coefficient of x power 8 is given by 55 square minus 10 into 11 into 21 by 6 by 2. Yes, I think you are following. So you should first recall this. X minus a1, x minus a2, x minus an. When you multiply, you will get x power n minus sigma a1 into x power n minus 1 plus sigma a1 a2 into x power n minus 2 minus sigma a1 a2 a3 into x power n minus 3, etc., etc. So x power 10 like this you are going to get. X power 9 is direct calculation. So you can do the problem like this. This you can simplify and get the value of S. You can do one more problem like this. Coefficient of x to the power of 10 in x plus 1 into x plus 3 into x plus 5, etc. x plus 20, x power 10, x power you write otherwise 8, x plus 21. So 2n plus 1, 21, 1 to 22, 11. X power 9 right, better. X power 9. X power 9 in this. Coefficient of x power 9 in the expansion of this. So this I hope with the same spirit you can do it. See, the next question is A, B, C, D 4 distinct real numbers which are in AP. Then find the positive value of K such that 2 into A minus B plus K into B minus C whole square plus C minus A whole cube is equal to 2 into A minus D plus B minus D whole square plus C minus D whole cube plus C minus D whole cube. So you have to find out the least possible value of K satisfying this. See, whenever there are 4 numbers which are in AP, you can choose them like this. A is x minus 3D, x minus 3y. B is x minus y. C is x plus y. D is x plus 3. You simply substitute A minus B means how much will get minus 2y. So minus 4y plus K into B minus C whole square means 4y square plus C minus A means what? 4y whole cube, 64y cube is equal to 2 into A minus D means minus 6y plus B minus D. B minus D is minus 4y whole square, it is 16y square. C minus D minus 2y. Minus 2y whole cube is what? Minus 8y cube. You will get like this. Understood? Now this is 64 plus 8 and 72y cube plus y square into the 4k, right, minus 60 y square. Next minus 4y plus 12y. There plus 8y is equal to 0. You can cancel throughout what 4 because 4 you can take outside, y also you can cancel. So your y cannot be 0 because they are distinct, so y cannot be 0. So if you cancel, what you are going to get? 18y square plus k minus 4 into y plus 2 is equal to 0. You will get like this. Remember, y is what? Real. So this quadratic equation in y will have distinct roots. So k minus 4 whole square minus what? 4ab. 4ab into 8 into 18. So 18 into 18. 144 greater than or equal to 0. So delta greater than or equal to 0 you got. So k minus 4 whole square greater than or equal to 144 mod k minus 4 greater than or equal to 12. So what you will get if you solve this? K minus 4 greater than or equal to 12 or k minus 4 less than or equal to minus 12. So k belongs to minus infinity to minus 8 union 16 to infinity. So least positive integer value, least positive value of k is what? Least positive value of k is how much? 16. So you have to think like this. It's a very simple question, very simple idea. Just substitute, get a quadratic in common difference. How about the common difference, of course? Write delta greater than or equal to 0, you will be through to the problem. Yes, I think you are following the problem. See, the next question is ax square plus a plus d into x plus a plus 2d is equal to 0. Ax square plus a plus d into x plus a plus 2d is equal to 0. So this is a quadratic equation. Of course, a plus d, a plus 2d are in what? AP. I mean, the coefficients of the quadratic equation are in increasing AP. Are increasing AP. Mean 3 consecutive terms of increasing AP. Then least integer value of d by a. Least integer value of d by a such that the quadratic equation will have real roots. So if the quadratic equation is having real roots, what must be the least integer value of a? That is the question was. Right? So the next question is, a and b are positive integers. Number of ordered pairs a comma b such that 6a, b are in harmonic progression. A and b are positive integers. Number of ordered pairs of positive integers a comma b such that 6a, b are in HP. See, when these 3 things are in AP, all of you know a is equal to, see, this is equal to 2 into this by this plus this. Means 12b by 6 plus b unit. A is equal to 12b by 6 plus b. Because x, y, z are in HP. Implies y is equal to 2xz by x plus z of this. Now from this you calculate b value. 6a plus ab is equal to 12b. 6a plus ab is equal to 12b you got. So from this you send this to the side. 6a is equal to b into 12 minus a. Right. So b is equal to 6a by 12 minus a. This is what you are going to get. Remember, a and b are what? Positive integers. Now you have to inspect a values. A is equal to 1. Is b is integer? No, because you will get how much? 6 by 11 cannot be integer. A1 fails. A is equal to 2. You will get what? 12 by 10. Is it integer? No, 2 fails. Then 3. You will get 18 by 9. So 3 holds good. Next, a is equal to 4. You will get 24 by 8. So integer. A is equal to 5. A is equal to 5 means you will get what? 30 by 7. 5 fails. A is equal to 6. 36 by 6. Okay, 6 okay. A is equal to 7. So 42 by 5 fails. A is equal to 8. 48 by 4. Okay. A is equal to 8. A is equal to 9. You will get 54 by 3. Okay. A is equal to 9. A is equal to 10. You will get 60 by 2. Okay. A is equal to 11. A is equal to 11 means how much? 66 by 1. Okay. So, what are all possible values of A? 3. So, the possible values of A are 3, 4, 6, 8, 9, 10, 11. For every possible value of A, there corresponds to B values. So how many ordered pairs of integers are there? 1, 2, 3, 4, 5, 6, 7. There are 7 ordered pairs of integers such that 6 A, B are in HP, where A and B are what? Positive integers. Right? I think it's a very simple question. These are all typical questions as far as the mains examination is concerned. Yes, I hope you followed this. Yes, our next question is ABCD are 4 distinct real numbers. 4 distinct real numbers which are in AB. Which are in AB. Then the smallest value of K. Smallest value of K such that 2 into A minus B plus K into B minus C whole square is A minus B minus C whole square plus C minus A whole square is equal to 2 into A minus D plus B minus D whole square plus C minus D whole square. See, the question is very much clear. A, B, C, D are 4 distinct real numbers. 4 distinct real numbers which are in arithmetic progression. Then the smallest positive value of K. Smallest positive value of K. Smallest, we write positive value of K. Smallest positive value of K satisfying this equation. This is our next question. Right? You first think on this. It's a very, very simple idea question.